Okay, well, hi everyone. Thanks to Beth and Bryony for organising this meeting. I'm Alison Pamment. I'm a member of the Data Request Task Team, but I'm also a member of the CF community and have been involved with CF for many years now, nearly 20 years. And one of my roles there is looking after the CF controlled vocabularies, one of which is the standard names, which is used for physical parameter naming, which is obviously very important, although we do have a couple of other controlled vocabularies in there as well. And it's really nice to get this chance to talk to people from the CMIP data request, because over the last few phases of CMIP, I've been involved, I think, in CMIP3, CMIP5, CMIP6, and now CMIP7, and each time there's been a phase of CMIP, it has led to quite a lot of new CF standard names being proposed. But in some ways, it hasn't quite felt like the CF community has been quite part of the CMIP process. But so now having the chance to talk to everyone today, hopefully means we can get some smoother communication going between the two communities, which I hope will help speed things up in terms of agreeing metadata and so on. So what I'm going to cover today is, first of all, just a couple of definitions, which according to the data request, what do we mean when we're talking about physical parameters and variables? What is the difference between those two things? It's good to be clear about that. And then I shall go over some of the basics of what is a CF standard name. So what does a standard name look like? How do you go about constructing one? What sort of rules does it have to follow to be a valid CF standard name? I will take you briefly step by step through the process of proposing a new standard name, because quite a few people will probably need to do that. That's something that happens on GitHub. And then towards the end, I've got some slightly more technical examples of how to when to apply for a standard name, and also when you should perhaps use some of the other metadata attributes in CF. So it's sort of the dividing line between what's a physical parameter and what is a variable, and there's a bit of a grey area between the two. So hopefully that will become clearer as we go along. So first of all, then some definitions. So according to the CMIP7 data request, physical parameter has a parameter name associated with a single CF standard name. And so this is literally the quantity that is being calculated, the thing that you're outputting from the model. So it could be something like air temperature, seawater salinity, precipitation flux, and so on. None of these have any geophysical coordinate information attached to them. There's nothing about temporal sampling or anything like that, or any kind of statistical processing. It is literally just what is the quantity that is being modeled. And the data request have set up a form for people to propose a physical parameter to CMIP7. And as part of that form, it will ask you, is there an existing CF standard name that you can use to describe this parameter? If it's a parameter that's already been used in CMIP6, for example, there probably is a CF standard name for it. If it's something that's very new to CMIP7, then there may very well not be a CF standard name, and you will need to propose a new one. A variable is something that starts with that physical parameter and then adds on to it some of the other information. Like I said, for example, time processing. So the example on the slide is near surface air temperature, where the temperature is the physical parameter. Then you've got something called amon.tas, which is monthly mean of the near surface air temperature. So it's got some sort of time sampling information, and it will probably have other grid information with it as well, whether it's latitude, longitude. If it was a 3D field, then it would have, might have pressure levels, model levels, and so on. So all of that additional information about the shape and size of the variable inside the data files, which is important when we're thinking about archiving data. That this affects obviously the size of the CMIP archive ultimately. So in terms of talking about the data request, so the CMIP7 website has a section on the data request and how to contribute to that. And what I'm talking about today is really going to be about the top section of this diagram. So if you need to submit a new physical parameter and deciding whether or not you need to also submit a standard named proposal, and you may also then need to submit a variable proposal to CMIP. So it's sort of looking at these sections of the process, if you like, for contributing to the data request. So let's move on then and actually talk about some CF metadata. So what's a CF standard name? Well, firstly, just taking a step back and saying, what is CF metadata? In general, it is a set of metadata conventions. I put a link there to the CF website where all the documentation about the CF conventions can be found. The aim is to define metadata that provide a definitive description of the data in each variable, its spatial and temporal properties, things like units of measure, any other statistical information. And the reason for wanting to do this in a standardized way is simply to aid interoperability. If you store your data in a standardized way, then you can use standard software tools then to extract data, regrid it, visualize it, and so on. So it just makes it so much easier for sharing. And for an exercise like CMIP, I mean, that's extremely important, of course. The CF metadata conventions are designed to work with the NetCDF portable file structure. So you don't have to worry about what hardware your file was written on. You can transfer it around and it should work no matter what your system. So it's completely transparent, completely portable everywhere. And as part of those metadata conventions, we have something called the CF standard name table, which is a long list of physical quantities that have been agreed. So currently we have, we publish versions of the standard name table every couple of months or so. The most recent published version is version 85, and we've got just short of 5,000 different parameter names in there at the moment. We're preparing version 86 this week, so hopefully in the next few days that will appear. We're getting very close to the 5,000 parameter mark. We'll probably exceed that, I should think, by the end of the year, and certainly if we get a lot of proposals coming in from CMIP. Okay, so what is a standard name? Well, it is just essentially it's a string. It's a unique string that is attached to a data variable inside the CF metadata, and it identifies the geophysical quantity. So that's the same thing as the physical parameter in data request parlance. So in this example here, we've got a single variable. Inside the netCDF file, it's just got a variable named PSL, and it's got some latitude and longitude coordinates. You can see it's got a metadata attribute for units. It's measured in hectopascals, and it has this standard name attribute. And the standard name value here is pressure at mean sea level, which is easier to interpret than just PSL. Why are standard names important? It's precisely so that we can identify what the variables are. So if, for example, I have a temperature variable, inside the netCDF file, I could call it anything I like. It could be temperature, temp, T, XYZ, myvar, anything at all. That's okay as long as I'm only using that data set myself. But as soon as I want to share that with other people, it becomes really important to be able to understand what the physical parameters are. And the standard names facilitate that process by providing an unambiguous agreed string, which has a description and agreed units, so that people can tell that whether two variables from different data sources can be compared in a meaningful way. And here I've got just a couple of examples taken from the standard name table. The most important components to note, the standard name itself. So here we've got a couple of examples: air temperature anomaly and surface upward latent heat flux. And if you browse the standard name table on the CF website, you can click on each name and the descriptive text will appear beneath. So we're standardizing not only the name that we're using for each parameter, but actually the meanings of it. So where a phrase turns up in multiple standard names, for example, anomaly, we say anomaly means difference from climatology, it will always have that meaning in all the standard names where it's used. So we're standardizing interpretation as well as nomenclature. And the other important thing is the canonical units. I'll explain in a little while why they're called canonical units, but this is effectively setting the physical dimensions of the quantity. So for temperature, for example, canonical units is Kelvin. For a heat flux, what's per square meter? So what are the basic rules for writing CF standard name? Well, first thing to say is if you have something labeled with a standard name attribute, which all CMIP variables should be labeled as standard name attributes in the end in the CMIP archive, then the value of the standard name must be drawn from the published standard name table. So it's fine if something is in there and you choose, say, an existing standard name like air temperature. What you can't do is use a standard name attribute and say standard name equals XYZ, for example, because it's not in the published table. So that would be not CF compliant. Standard names consist of letters, digits and underscores with no white space. So we've already seen a few examples of that. So the underscores are used to connect the words. They're in English language with US spellings. I do emphasize this because so things like vapor, spelt the American way, sulfur with an F, things like that. As a British person, I sometimes even now trip over this myself and have to remind myself to use the US spellings, but that is the way it's standardized. The standard names are case sensitive. Most of them actually only use lowercase. I think the only situation at the moment currently where we do use mixed case is where we've got chemical element symbols. So like in the example here, we've got an isotope of silver. So it's written 112 for the atomic weight and Ag as you would see it in the periodic table. Other than that, I think we always use lowercase. I'd say almost all standard names do have an accompanying description. There perhaps a very small number, 10 or 20 or so of some of the standard names that have been around the longest since the beginning of CF that may not have descriptive text, but we're trying to slowly add descriptions for all of them. So when you apply for a new standard name, we will also ask you to help to create the description for it as well. It's important that we have that sort of definition text. One thing to note as well is that once a name has been added to the standard name table, it's never removed. This is really important because data that was written 20 years ago that was CF compliant will still be CF compliant today. We don't want to suddenly invalidate data that were written a number of years ago by suddenly changing the standard name and it disappearing. Doesn't mean that we can't modify a standard name. For example, if there were a spelling mistake or if we can agree better or clearer terminology for a standard name, we can update it, but then the older version of the name is still maintained as what we describe as an alias. So that's kind of a deprecation mechanism, but there will always be a record of previous versions of any standard name. And the rule there is simply if you've got old data and it's got the older versions of the name, that's completely fine. It's still valid, CF compliant metadata. But if you're writing new data, please use the newer version of the standard name. That's really the basic rule there. So moving on a little bit more, how do you actually construct a standard name? Now, this may look rather complicated to start with, because we do have a kind of grammar for constructing the standard names, but hopefully I can explain this a bit more by means of a few examples. So the main thing to start with is this thing called I've called it the base quantity. This is something that could have a standard name in its own right. So the physical parameter, we just talked about, for example, air pressure. But then we can add some additional qualifiers to describe that more precisely in the standard name. So in the first example, we've added the qualifier surface. So surface in this case would be defined as the lower boundary of the atmosphere. So we've got surface air pressure. So we do have some special named surfaces in CF. So surface is one of them. Tropopause would be another example, top of atmosphere. So there are a few of those, cloud base, cloud top, things like that. Occasionally, we have a special surface that does have a name, but it's not just something that can be summarized in one word. So there's another example here, air pressure at convective cloud top. If it's a sort of multi-word phrase to describe the surface, then we tend to use this other syntax. So rather than putting convective cloud top air pressure, we do it this way around, air pressure at convective cloud top. That is just the convention that's been agreed for a long time. But essentially it's conveying similar information. There's also the possibility of defining a sign convention. So if you've got something like a flux of water vapor, carbon dioxide, for example, you might have an upwards or a downwards flux, or northwards, southwards, eastwards, westwards, so on. So the component of that is written in this way, downward. So that will imply that any downward flux is a positive sign, and the negative number implies it's an upward flux. So that's defining the sign convention for your data. Medium means essentially what's the surrounding environment in which this quantity applies. So something like water vapor flux probably only makes sense in air. But if you had something that was, say, a heat flux, that could apply equally in air, in seawater, in soil, for example. So having the medium in there helps again to disambiguate between quantities that could apply in more than one medium. And then you can also, because it's model data, and you might want to look at the contributions to a total flux from different model parameterizations, you can add a process description. So we can say something like due to diffusion, or it could be, I don't know, due to boundary layer mixing. There's quite a lot of these processes have already been defined if you look at existing standard names. But that's a way of if you're interested in studying particular processes due to particular parameterizations in your model, that's a way of describing that. And then finally, we have this qualifier of assuming. This is used quite a lot, I find, in radiative names. So where we're applying an extra condition to the standard name. So net downward long wave flux in air, assuming clear sky. So these are quite long strings, but the idea is to be as precise as possible about describing the scientific variable, and to be as unambiguous as possible, even if it does lead to quite a long string sometimes. One thing that does sometimes confuse new users of CF metadata is, can you have more than one variable having the same standard name in one file? And the answer is yes, you can, because inside the netcdf file, you will have different variable names. So in this example, I've got wind speeds at two different locations. So I've got a variable called WSA at one location, latitude and longitude 1, and it's got a standard name of wind speed. I've got another one, WSB, at a different location, latitude and longitude 2. It also has a standard name of wind speed. That's perfectly valid CF. So people sometimes worry that that's wrong, but no, that's absolutely fine. Okay, I did mention canonical units, and this is a point I would just like to emphasize as well. Something that also does confuse new users is that the canonical unit is used to set the physical dimensions in the sense of mass, length, time, temperature, and so on. The units you use in your data file need to be physically consistent with the canonical unit, but they don't have to be identical. So for example, if you've got a temperature and the canonical unit is Kelvin, it's still okay to use degrees Celsius in your file if that's what you prefer to use. Or if it's got a canonical unit of seconds, but you want to report your values in years or days or something, that's fine. The reason that's okay is because any software that implements the CF conventions will rely on a particular software package called UD Units, or it's UD Units 2. and that will convert between equivalent units. So when software is checked for compliance with the CF metadata conventions, as long as you've got units in there that are compliant with the canonical units, that's okay. That will pass compliance checking. Okay, so how do you go about proposing a new CF standard name? I'll just take you through this step by step to begin with. The very first thing to do, I should say, if you don't have one already, is to sign up for an account on GitHub, because the place where the CF conversations, the community conversation happen, is all on GitHub via GitHub issues. I think that's true also for some of the data request conversations. So many probably already have a GitHub account, but if not, it's a simple process to sign up, and it's free to do so. You just provide a username and a password, essentially, and then you're ready to go. Now, the place to propose standard names, it's got this rather long, so it's in the CF convention organization, and the vocabulary repository of that. Now, what I would say is don't worry too much about remembering this, because the form in the data request where you can propose a physical parameter does also contain a link to help you to propose a standard name. So you don't need to worry about being able to find this link again. It will take you to the same place, although you can, of course, navigate to it directly in GitHub. And to see this view, what I've done is across here where I've got the different menu bars, I've clicked on the Issues tab, and you can see down here a series of issues. And actually, I took this screenshot yesterday. We already have a couple of issues where people have started proposing standard names for CMIP7, and we've actually created this GitHub label. So when you do make a proposal for a standard name, if you could please include the word CMIP7 in your title proposal, that will help us with triaging and making sure that we're processing your names properly. And we will add this label as well. It just makes it easier within the CF team to see what we're working with. So yes, so somebody's already proposed some C-level names for CMIP7. And then you need to open a new issue, which is just by clicking this green button here. Very straightforward. And then it asks you to select a template. So there's a couple to choose from, but the one you need to use is the standard name template. It's fairly self-explanatory, and press the green Get Started button. You can, if you wish, open a blank issue, but really we prefer that you use the standard names template, because then once you open that, you will find that there's some information in there, some guidance as to what you should include in your proposal. So it will help you to actually write your standard names proposal. So it will ask you to add a title. So as I say, if you can include the word CMIP7 somewhere in there, that would be great. And then it asks you to put in some information like your name. I mean, you don't have to put your name in. You could just use your GitHub handle, but we like to give people credit. We maintain a list of standard names contributors, and we like to give people credit for helping to maintain the CF conventions. So if we have your name, then we can credit you as one of our contributors. And you will be asked to put in the date, and then it will ask you to propose your names. So your name, a suggested description, and your canonical units. And what we do ask as well is if you've got multiple standard names for similar quantities, rather than opening a new issue for every single standard name, we'd rather you group a few of them together within a single issue. It makes it easier for the conversation if they can be discussed together within a single issue. So moving now to the CF community discussion process, I should be clear with you that simply proposing a standard name through this method doesn't automatically lead to acceptance and publication in the standard name table. There is a discussion process that follows on from this. This is within the CF community. It isn't a duplication of the CMIP 7 data request discussions. where people are discussing what variables should be in the data request and why they're needed to answer the scientific questions. Once you've proposed a standard name, we will assume that yes, you do need this variable. But what the discussion in the CF community will be about is establishing exactly what the metadata requirements are to describe your physical parameter as accurately and as unambiguously as possible. We do ask that the proposer does engage with the CF discussions. I mean, this is open to anybody in the CF community to comment on your proposals. People may ask questions about it. They may suggest improvements and modifications. We do ask you to engage with that process to help move things forward, and there will be a moderator to also help move the process forward. I'm one of the moderators. There are two other people who will do that as well. And because of this discussion process, it is possible that the final accepted version of the standard name, the one that gets actually published in the standard name table, may look different from what you initially proposed. But I hope that from this discussion process, what we end up with is something that is it's the best possible choice. So it's an improvement, if you like. So yes, as I said, any member of the CF community can comment on the proposals. The aim is to achieve a consensus within the CF community. We do have detailed rules about when a name can be accepted. I mean, we don't have to have absolutely unanimous consensus. If we have nine out of 10 people agreeing, probably that would be enough to get a name accepted. We can fast track some standard names if it's something that's very similar to an existing name. So say you've got something which is mass concentration of a new gas that we haven't included before in CF, but otherwise the name is very similar to existing ones, probably just some preliminary checking, and we could accept that one very quickly because there's not likely to be a lot of conversation about it. But for names where we're introducing new terminology, there may have to be more conversation. If we did get to a deadlock about agreeing a standard name, which I don't think has ever actually happened in practice, but there is a community process in place where we can ask the CF committee to vote, and their decision is final. So if we're choosing between option A and option B for how to write the standard name, they will vote on it, and so we can break the deadlock that way if we have to. But that's never actually happened in practice. And then one of the things that will happen is your proposal will also get added to something called the CEDA vocabulary editor. This is really just something to do with behind the scenes, how we actually process the names and prepare them for publication. But you will be able to see the progress of your proposal in there as well. So something that's got this amber bar it means it's already been accepted, it's ready for publication, and we'll go into the next published version of the standard name table. Something with this greenish coloured bar is still under discussion. New names, I think, have a blue bar and so on. So you can see at a glance where your names are through the discussion process. So moving on, I'll just pause for a moment and ask, does anybody have any questions about anything I've said so far about the process? If not, I'll proceed then to just talk about some things that don't go into the CF standard name, because again, if you're very new to the CF process, sometimes it's tempting to try and put a lot of information about your variable in the standard name itself. So a particular thing is using vertical coordinates. So if you've got something, we don't put numerical information in the standard name. So if you've got something like a 2-meter air temperature, we would just use the standard name air temperature. And then we would add an additional vertical coordinate with a standard name of height, and we would give that a value of 2. Okay, so this is using an additional CF metadata attribute rather than writing it as a 2-meter air temperature in the standard name. Now, the reason for doing this is because we don't want a huge proliferation of standard names which are almost identical to one another, except that they differ in some numerical coordinate. So, for example, you could have 2-meter temperature, 10-meter temperature, 50-meter temperature, and so on. Rather than having that, the vertical coordinate information goes into a coordinate variable. In this case, a scalar coordinate variable with just one value. So that's one example. It can also be useful, actually. The thing about using a coordinate variable is that you can actually describe a layer. So if you've got for example, in this slide, we've got a liquid water content of a soil layer. So a layer defined between two soil depths. And by having a vertical coordinate of depth, and giving that a bounds variable now, so we're using something. This is another metadata attribute. This is attached to the vertical coordinate variable. We can then say that it has a value of 2 meters, but boundaries of between 1 and 3 meters. So you can actually define your layer. That is much more information than we could capture by just trying to write everything into the standard name. So there are benefits to actually using some of these other metadata attributes rather than trying to cram all the information into a long string. I did mention earlier as well that, however, we do have some special named surfaces or layers. So they would go into the standard names of something like surface temperature, cloud base height, or troposphere mole content. So they are allowed into the standard name, but those are not numerical values. You can also use coordinate variables if you've got a non-geospatial dimension. So for example, if you've got something which is a spectral quantity, so some sort of radiative quantity like atmosphere optical thickness due to convective cloud. Now, generally speaking, that optical thickness would be assumed to be a mean over all optical wavelengths, unless you also add a scalar coordinate variable with the name of radiation wavelength and give that a value. So here we've added an additional coordinate variable with the name radiation wavelength in units of nanometers, and we've given it a value of 740. So now we're saying that this atmosphere optical thickness applies specifically at that wavelength. So this is another way that we can supply some richer metadata through using some of these other metadata attributes, rather than, again, trying to just squeeze it into the standard name. I have here another example. Actually, I think it's taken from CMIP7, where using non-geospatial coordinates and scalar coordinate variables can help us describe something that would be really complicated to describe in the standard name. So originally, we do have a standard name for sea ice thickness with units of meters, and it was proposed that what we wanted was to have a variable like this where sea ice thickness applied only to categories of sea ice. So categories in terms of sea ice age, so first year sea ice, multi-year sea ice, and so on. We could try and write that into a standard name. So you might come up with different standard names such as thickness of first year sea ice, thickness of multi-year sea ice, and so on. But again, that proliferates standard names. And also, you'd then have to start thinking about, well, what's first year sea ice? What do we mean? Does it mean it's exactly a year old? Is it something between 6 months and 18 months old? We'd have to start defining all of that and writing that into the standard name descriptions. And also, it's written in those descriptions. It's not very machinable. It's not so easy to get at that metadata when you're analyzing your data. So a better approach for this was instead to use the existing standard name, age of sea ice, but then add an additional coordinate variable. To use sea ice thickness as the existing standard name, and then add additional coordinate variable with the standard name age of sea ice. and have that in years, and we could give that some values. So you can have 1-year-old sea ice, 3-year-old sea ice, 10-year-old sea ice, and so on. So you could have a whole array of these things. And again, we could add coordinate bounds to this. So we could use the coordinate numerical bounds to say what we mean by year-old sea ice. So if 1 year means 1 year plus or minus 6 months, you can describe that in the coordinate bounds. So we get a much more powerful and richer mechanism for describing the variable in a machinable way, rather than trying to write complicated standard names. So it does pay to spend some time sort of taking the variable apart a bit and deciding how to use the other CF metadata attributes. Another metadata attribute is really useful to know about in CF is the cell methods attribute, which is used for describing statistical processing or sampling, I should say, and post-processing. And Appendix E of the CF conventions describes the values that can take. Cell methods can also be used to describe different statistical processing on different axes of your variable. So you may have something that's air temperature, which is a mean over area, but a maximum in time. So you can express that in the cell methods attribute. And the order in which you write these from left to right says how you applied those operations. So if you've got something, a statistical operation where something's being processed one after another, so you can say, well, first I took the area mean, and then I found the maximum in time. That's what you're expressing in this. Again, that's not something you could easily express in a standard name. And cell methods is also very useful in being able to describe statistics for portions of a grid cell. So for example, if you want something like the mean surface albedo over the snow area, so you can have a cell methods which looks like this. So you say area mean. So I'm taking mean in the horizontal, where sea ice or where open sea or where grassland or something like that. So you again you can capture all of this information, but it's done in other CF metadata attributes, not in the standard name. Okay, and I think this is my final slide on this. What happens if we can't fully standardize what's in the scientific variable? For example, if you've got different accounting techniques in different models. An example of this would be something like the mass concentration of alkanes in air, where everyone can agree what an alkane is, so it has a particular chemical formula, but different chemistry models may explicit in the model just a certain number of alkanes. It may be different numbers of alkanes that are modeled on different occasions, and so we can add a comment attribute in the CF metadata to explain exactly what was modeled in your particular model, but we can use this sort of group chemical name, but we can't standardize it further in the standard name. Okay, so I will stop at that point. I realize I've gone through quite a lot of detail there. I hope I haven't taken too much time. I just wanted to share this link with you as well. There is a CF community meeting coming up next month in Sweden. The link to it is there. I know the IPO have advertised this for us as well. But if you're interested in participating more in the CF community, please do consider joining our meeting as well. Okay, and I will stop there and see if anyone has any questions.
Thank you so much, Alison. That was a really, really clear and informative talk. Yeah, we've got 15-20 minutes or so to take some questions. If people have any for Alison, feel free to just either unmute yourself or pop your hand up. Yeah, Fiona.
Thank you. And I iterate what Beth said. That was really clear and very useful. I have two questions, if I may. One of your examples was on pressure at mean sea level, and you used a short name, PSL. How do we get those short names, I think, are they called output variable names, agreed, such that there's a link between that short name and the CF standard name?
So I think that's done. I'm sure Beth and Brian will correct me if I'm wrong, but I think that's done at the data request level. So when you are looking at proposing a physical variable, a physical parameter rather, if it's already been used in a previous phase of CMIP and there is a database of those, you should be able to find what short name it's already been given in CMIP. So the PSL there was not the CMIP short name, I should hasten to add. It was just the name inside the netcdf file. So it's within the data request process when you propose a physical parameter that I think you would propose a name for it there, what it's going to be called inside the CMIP data request.
Is there a list of those available that we can cross-check against whether something's been in use already?
I believe yes. If you go to those forms, certainly if you go to the CMIP7 website and the section about the contributing to the data request, there is all the documentation there. Yeah, Beth just posted a link, but yeah, there is a database of things that have already been used.
Okay. My second question then is the interaction between the CF convention and the data request. So we're obviously building opportunities at the moment to input to the data request. If something isn't currently in the CF convention, is that still okay to propose on the assumption that then we would propose it for inclusion in the CF convention?
I think the way the process works is if when you fill in the form to propose a physical parameter, the form says what does this parameter have an existing CF standard name? If so, what is it? And you can again, you'll probably find that in the database, the data request database will show what standard names have been associated with which CMIP parameters if they've been used already. If it's a parameter that's very new and hasn't been in previous phases of CMIP, then there is a link to say, please propose a new CF standard name and put the link to your proposal here. So that that is gathered through the data request process, so that it's transparent to everyone that it is being discussed, it has been proposed, and so on. I mean, one thing to say about that, about my examples there at the end, although you're proposing a physical parameter, it is a fine line between what is just a physical parameter in terms of having a standard name and what may require some other CF metadata attributes. And part of the process of discussing the standard name may lead to us coming back to you and saying, well, actually, we think you need to use a cell methods attribute, or we think you need to also include a scalar coordinate variable to say what wavelength your radiation variable is at. And that might then need to be fed into your proposal for the for the CMIP variable. So it's the information needs to be sort of fed back in so that everything is consistent. So starting these standard names proposals earlier rather than later would be good. I mean, I think we've got until is it early September? When is the first consultation phase? It's early or mid-September, and it can take a while to agree these standard names, but at least having them under discussion as early as possible will help to expedite matters.
Brilliant. So, thanks for the comprehensive responses to my questions. Thank you.
Okay.
Thanks, Fiona. Have we got any other questions for Alison? I'm not seeing any hands right now. I will just say to everyone that this presentation has been recorded and we will be uploading it so you can watch it back in the future, and the slides will also be available. And if you have any other questions that sort of arise after the session, please just feel free to reach out to Alison and or the IPO, and we'll do our best to help you wherever possible.
Yeah, I would just say as well, even if you're not sure exactly what your standard name should look like, don't let that dissuade you from proposing it. And say there are moderators in the CF community, and we will try to help you. So even if your proposal isn't exactly in the right form, you know, we will help you sort something out. I hope I haven't frightened everybody in thinking that they've got to have everything absolutely perfect for first time around. That's not true.
Great, thank you so much. And I guess also just to finally reiterate something that Alison said, please do, especially if you've got new physical parameters that you think you need to propose with new standard names, please do propose them as soon as possible so that that discussion process can get underway and hopefully be resolved in time for the end of the first phase of this consultation, which is the 8th of September. So just as a final note to everyone, so thank you so much for coming. As I said, you'll be able to find the recording and the slides after this session. All of the links to contribute to anything on the CMIP data request, from physical parameters all the way up to opportunities, are available on our website at this link. And there is also this kind of flow chart to help you figure out at what stage you need to contribute and where you need to start, including this kind of process of submitting a CF proposal. So thank you again all for coming, and thank you so much, Alison, for your great presentation, and we will be in touch soon. Thank you.